So this is LeetCode 886, possible bipartition. Um, and given a set of n people numbered 1 to n, we would like to split everyone into two groups of any size. Each person may dislike some other people, and they should not go into the same group. Formally, if dislikes I equals AB, it means it is not allowed to put the people numbered A and B into the same group. Return true if and only if it is possible to split everyone into two groups in this way. Okay, so just a second here. So we basically have this situation with example 1 going to 2, 1 going to 3, and 2 going to 4. And this is a bipartition because we can split all the vertices into two different sets where every edge starts in a set A and ends in set B. And we can and likewise every edge that starts in set B ends in set A. And then if we look at example 2, we try to split the graph into a bipartite set, but we have an edge starting in B and ending in B, and that violates the bipartite set principle. So this is not a viable bipartition. For example 3, we have 1 going to 2, 2 going to 3, 3 going to 4, 4 going to 5, and this 1 going to 5 starts in set A and ends in set A, and this violates the bipartite set principle. Okay, so we're gonna process. We're gonna go through the code here. So we're basically processing neighbors. We have a map for neighbors, and the neighbors of I is j. The neighbors of j is I. This is equivalent to saying the neighbor of 1 is 2. The neighbor of 2 is 1. The neighbor of 1 is 3. The neighbor of 3 is 1. And there's a mutual neighborliness that happens with undirected graphs. And then we're processing all the vertices. But if they've already been processed, if they've already been visited in our DFS, then we skip them. But we call it DFS. We call it BFS on every vertex that hasn't been processed. And then in our BFS, we have a queue. We pop left, and then we color it. Our starting color is going to be 1, and then there's only two colors, 1 and -1. And so we start with vertex 1, and for neighbors 2 and 3 are vertex 1. If we're looking at example 1 here, if 2 is not in colors, we color it as -1, and then we append it to the queue. And the same with 3. If 3 is not in the color map, then we color it with the negative color and we add it to the queue. And then if we get to a point where the if our neighbor is the same color as our starting vertex, then we violate the bipartite set principle. So if we look here, okay, we're coloring. You can see that that 1 and 2 are separate colors. 2 and 4 are separate colors. 1 and 3 are separate colors. 1, 4 are one set of colors. 2, 3 is another set of colors. But if we go over here, 2 and 3 are both in set B, but they are of the same color, B, because there's a edge connecting them. Likewise, 1 and 5 are of the same color, and that violates the bipartite set principle. And that just corresponds to this code right here, where the if our neighbor is the same color as us, we have violated the bipartite set principle as we return false. So let's run this and see if it passes.
All right, we passed in the 99th percentile. And we could also do this in DFS and I think also with set operations. Um, yeah, be sure to like, comment, and subscribe. Let us know if you have any follow up questions. Um, hope you guys have a great day. All right, OpHaxor out.